Stay tuned. Well, we are here for the next great episode of the Metaphysical Corner and the search. We're talking about consciousness and other sundry items. It's been an interesting week. I am right now myself going through, I'm very much into stones and crystals, and I've really been expanding my repertoire and my knowledge on that subject. I can't believe, the funny thing is, it's this whole metaphysical thing, and call it New Age if you want, whatever. It's amazing because it's the more, it's exciting and it's frustrating. It's exciting in that there's so much to learn, and it's frustrating in that the more I learn, the more I know I don't know. And I find that frustrating. But yeah, it's exciting. Because the learning never ends. You never know it all. I'm learning left and right. And, I'm sure I'll be learning till the day I die. But that's the kind of guy I am. So, but anyway, enough philosophical. So let's go on with the consciousness and the essence of it, where it comes from, and we're now starting to get into the heavier duty stuff. They start talking about DNA. I know I've touched on it before. DNA, which stands for deoxyribonucleic acid, if I remember, is a, it's kind of like it's both. It's simplistic and it's complex beyond belief. The actual strands, it's the double helix. We've all seen pictures of it. Is simplistic in its design, but the complexity of it is beyond belief. But yet it's so simple because there's only 4 of what they call bases, BASES, which go into it. That's it. In everyone's DNA. You have in your body, let's say you have 500 billion cells in your body, whatever, or whatever the number really is. Each one has a set of the DNA and are all identical. They better be, and because when millions, if not billions of times a day, your DNA is duplicated, and cells die and new ones are made, which is a constant thing in your body, and there better not be any mistakes when it's duplicated, because fortunately there even has check mechanisms to correct errors as it's doing so. But if there are mistakes, that's sometimes the causes of diseases, and even cancer is a basically it's DNA mutation that for the most part I believe causes that and creates cells which when cells grow they're supposed to grow to a certain point and stop, and that's all decoded in the DNA. But if something happens with that gene that decodes that, the cell won't stop growing. That's what cancer is. There's a cell that is growing out of control, won't stop. That's what a tumor is. So, it goes to show you, but it's fun. So, that's just the physical end of it, so to speak, the chemistry end of it. Where it comes in is the metaphysical side of it. It actually has, I really do believe DNA picks up information from the universe. It's even in the shape of an antenna. And we're talking about, once again, energy. Radio energy from the universe, the planets. That's basically how I think astrology works. If the planets have an impact on us, it's done so through energy from those planets, which is picked up in our pineal gland, and then transferred to the DNA of all of the cells in your body. So let's go on with this. Let's see what it says, and I'm sure it will touch on this. It says DNA is a molecule that contains millions of atoms. It's found in all the cells of living organisms, from the most simple to the most complex. We know it is the central and largest data bank of any organism. According to biologists, it contains the structure of all the information to recognize and duplicate all of our cells. So yeah, you could take, literally, if we had the technology, you could take one of my hair cells, well, if you could find some, and duplicate me. It would duplicate me, but of course it would duplicate all my experience, my knowledge, but you would make a duplicate of me, or you could. Our DNA knows, and they got knows in parentheses, knows all about our size, color of our eyes, hair, and our skin. Our DNA knows our constitution and its makeup. It also knows about our ancestors. It contains all our genetic past from all generations. In fact, the term DNA does not refer to a specific molecule, but a group of molecules. Imagine a group of, now this is really important to try and imagine this. Imagine a group of necklaces all made of 4 kinds of pearls. This is the basis that I talked about earlier. From one living species to another, it is only the length of these necklaces and the order of the pearls that vary. For example, it has recently been discovered that only 7% of DNA is different from the DNA of a macaque. Between humans, DNA is 99.9% identical between every person living on this planet. This means only 1/10 of 1%, 0.1%, not 1%, 1/10 of 1% of the DNA of any 2 human beings is different. And that would be more physical characteristics than anything. And the difference between your DNA and that of your parents is even smaller. Nevertheless, each human being's DNA is unique. Throughout human history, there has never been another human being like you with exactly the same DNA, unless you have an identical twin. And there will never be another being like you. You are unique. And as long as the cloning of human beings remains fiction, you will remain unique until the end of time. Thus, your DNA distinguishes you from all other beings on the planet. Don't worry then if sometimes you feel different from the rest of the world. You are. In each of its 50,000 billion cells, so I don't know, whatever the number is something that no one else on Earth possesses but you, and no one can take from you. We may be merely made of nearly empty atoms, but nevertheless science confirms that each of us is unique. Biologists believe that information passes from one molecule to another by means of reactions in which the molecules touch one another. Well, they have to. These interactions can be conceived as the meeting of 2 molecules with complex structures. One has the shape of a lock and the other is a key. This is where enzymes come in, for the most part. Only when the key comes in contact with the right lock does a reaction take place and the transmission of information is made. In other words, the information carried by one molecule is transmitted to another only when this molecule has been identified by its structure. This arrangement ensures the selectivity necessary to maintain order between constantly reacting molecules. Without this selectivity, we might grow nails under our tongues or teeth at the tips of our fingers. Okay, I don't sound very pleasant. Now we get into the quantum revolution. Here we go. This is when it starts getting really interesting. Thanks to the genius of Sir Isaac Newton, from the 17th century until the beginning of 20th century, we thought we knew all about the movement of solids, especially. From dust to stars, this motion was described with great precision by Newton's laws. What we still ignored was the nature of matter from which the stars and dust were made. We were far from suspecting that this discovery would completely change our view of the universe. At the beginning of the 20th century, Einstein finally ended the argument over atoms in that article he published in 1905 on Brownian motion. The existence of atoms and molecules was undeniable, and the atomic theory gained acceptance, and they started looking at atoms more closely. In 1904, the British physicist J.J. Thomson discovered that matter contained negative charges. Since atoms were electrically neutral, he theorized that the atom was a positive sphere that was stuffed with these negative charges like a raisin muffin. That the fact that the atom was totally electrically neutral was maintained. In 1911, his student Ernest Rutherford showed that there was indeed a positive sphere in atoms, but this nucleus was very dense and contained most of the atom's mass. Electrons were not stuck to it, but were far away. An atom has no longer resembled a raisin muffin, but a fruit with a kernel at the center. On the other side of the ocean, Millikan combined these results of his own and calculated the mass of an electron. Then came the discovery of protons and neutrons. And this must have been an exciting time. You're getting down to the nitty gritty, and every time they discover something, it just threw everything out in left field. It's like, I could see they must be going back. We talk about going back to the drawing board. In short, by the second decade of the 20th century, these experiments had enabled scientists to create the atomic model briefly depicted in the first part of this book. An atom contains a positive, very dense nucleus. This nucleus is composed not only of protons, but of neutral charges called the neutrons. Surrounding these very light negative charges, electrons, they move at great speed, and there is a tremendous void compared to their size. This was the only possible model consistent with the results of the observations made and confirmed by researchers on both sides of the Atlantic Ocean. But scientists knew there was something wrong with this model. It wouldn't work. And that's got to be, think about it, they're coming up with this as the best theory, best explanation I can think of for what they're seeing, but yet what they are coming up with, they know, is not the app. And maybe part of the answer, but it's not the whole picture. And according to Newton's laws of motion and the Scottish physicist James Clerk Maxwell's law of electromagnetism, the negative charge electrons going around the nucleus should have lost energy and crashed very quickly into the nucleus attracted by the positive charge. Obviously, this wasn't happening. Electrons remain in their orbits, much like the Earth maintains its orbit around the Sun, and did not crash into the nucleus. Something was wrong. This model is incorrect, but nobody had a better one. The embarrassment of scientists was enormous. The laws of physics were considered infallible, no longer applied. In other words, Sir Isaac Newton must have been rolling over in his grave because his laws of motion were taken as absolute, and all of a sudden, I'll end the suspense. What happens is, Newton's laws of motions work perfect, unlike a global scale or like a scale of what we know as existence. But when you get down to the subatomic and as such, Newton's laws of motion aren't worth the powder. Well, the hell. And that's putting it simply. Anyway, they couldn't explain why an electron didn't fall into the nucleus like a fly into a pot of honey. Newton's equations, which had all turned out to be as valid for a grain of sand as they did for the planet Saturn, did not apply. For the first time in over 200 years, Newton's laws had failed. These concerns, together with other unexplainable experimental results, forced scientists to reconsider what they believed to be the unshakable foundations of physics. And this reconsideration gave birth to the quantum revolution. After ruling the roost for more than 2 centuries, after successfully describing all the motions of the bodies of the universe from a grain of dust to galaxies, Newton's laws were superseded in less than 2 decades by new laws of quantum mechanics. Until then, Newton's laws had always done the job. They're not wrong, but they are incomplete and they don't apply. They do not work at the atomic scale. Matter that we know and that we are made of is indeed a collection of small entities, electrons, protons, neutrons. But these entities could not be conceived as tiny solids to which Newton's laws applied. Great imagination was required to find new equations that would explain how the electrons, which revolve at tremendous velocities, do not lose energy and end their frantic run in a tragic but unavoidable fall into the nucleus. Well, at the beginning of the 20th century, the work of physicists Max Planck and Albert Einstein established that light has a double nature. And it does. In certain experiments, it acts as a wave. And it propagates and may be refracted by a prism. In other words, light goes into a prism, comes out in rainbow colors, that's refraction. And there it acts as a wave. In others, it behaves as if it's all small, strange projectiles, invisible and without mass. The photons. Fire those photon torpedoes, Scotty. I'm sorry, I couldn't help that. These photons can be imagined as the drops of a beating rain that started pouring billions of years ago when light was born together with the universe and which have been falling on us since then at 186,000 miles per second, which is the speed of light. Inspired by these results, in 1924, a British physicist presented the astonishing hypothesis that matter has a double nature. I cannot emphasize how important this is and how much this is the crux of what is coming from this point forward. And it's not going to make much sense, but it is the case. Light, or the mass, not only does light have a double nature, matter has a double nature. A wave nature and a corporeal nature, that we know of. Like light, matter sometimes seems to behave as if it were waves, and sometimes would behave as if it was made of small beads. This physicist, his name is de Broglie, that's why I'm just saying physicist, forgive me, proposed that the equations that made it possible to establish the link between these two behaviors. That equation suggested that all moving bodies, whether as fast as light as the electron, or as slow and heavy as our own body, has a wavelength. I want to repeat that. That statement is heavy in its implications beyond belief. That equation suggested that all moving bodies, whether moving as fast and light as an electron or as slow as heavy as our own body, has a wavelength. And more importantly, every person and everything's wavelength is different. Once again, we're talking wavelength, energy. This wavelength depends upon the mass and the velocity of the moving body. In other words, any body, whatever it is, from dust to stars, could be regarded at the same time as both an aggregate of tiny beads and as a wave phenomenon that has something that has a wavelength to it. This duality had not been imagined previously before, because according to the equation, the wavelengths associated with them macroscopic objects were too short to be detected with equipment available. But his equation stipulated that when you hold a stone in your hands, although you undoubtedly feel that you are touching a solid body, well, to you a solid, you are in fact touching something that behaves like waves, even if we still can't detect it with our modern technology. This revolutionary description of matter aroused both interest and incredulity among scientists. You know, a lot of scientists said bullshit. As extravagant as it sounded, in 1927, de Broglie presented an extraordinary hypothesis. It was confirmed. Electrons have a double nature. In other words, the theory was no longer theory. In an experiment set up to study electrons scattered from metal surfaces, electrons did not behave like particles. They behaved like waves. They produced interference, one of the principal manifestations of a world of waves, and will not happen with solid bodies. According to the mechanics of solid bodies, if, for instance, two balls of modeling clay are thrown at each other, they will stick together and form a new body. It would be absurd to think that these balls would cancel each other out. Waves do. Darkness can be generated with light. Under a specific condition of rays of light having wavelengths are shown through two slits in a thin wall, and the patterns show that the rays make on a screen behind the wall are observed. There will be areas of strong light, as if the rays are sticking together, like the two balls of clay, and their crests are adding together. This is known as constructive interference. But there will be areas where the light is dimmed or has disappeared, and these waves have neutralized each other, and that's called destructive interference. In other words, adding waves together can destroy them. Interference is a wave phenomenon. It doesn't happen with solids. Light can cancel light. Sound can cancel sound. This effect is often exploited to neutralize radio waves as to limit background noise by transmitting waves of the same frequency in order to cause destructive interference. So, quantum physics was born, founded on this amazing hypothesis, which soon became indisputable fact. This new field developed very quickly and was crowned with success, but it required a juggling act. On the basis of the hypothesis, equations taken from the classical side of physics, like Newton physics, has to be combined with equations taken from the physics of waves. And thanks to the major contribution of Austrian physicist Erwin Schrödinger, is his name, very important physicist, this maneuver was incontestably successful. The mixed equations, the most prominent of which is Schrödinger's equation, works wonderfully. The experiments repeatedly confirm their precision. This new theory provided spectacular results in multiple fields and opened new areas of research, which gave rise to the computer. However, this mathematical manipulation generated a monster, something that was not even really a wave or a solid body. The bricks of our universe and of our own body have always had concrete and tangible form, had become a mathematical equation. So at the atomic level, matter could not be described other than by mathematical abstraction. No image was appropriate, and there's never been such progress since. This is an important paragraph here. The inside of an atom can be imagined as an immense skyscraper with a huge number of floors, each corresponding to a different energy level, and with a basement inhabited by the nucleus. Electrons dwell on these various floors according to their energy. The higher the energy of the electron, the further away from the nucleus it is. Since we have already compared energy with wealth, let's continue here and say the richer an electron is, the more it can free itself from the hold of the nucleus. Just as money does not circulate as a fluid, but as banknotes and coins, energy inside an atom does not circulate like a fluid, but in discrete quantities, the quantum. And what that means, and I think that'd be a good place to stop. Because I want you guys to think about this, and we'll pick up on this. And I may have said this before, so forgive me, but the way it works, what they're talking about here, quantum. And I think a lot of you might remember the series, the old TV series Quantum Leap. But that's what we're not talking about. And not going to talk about this, but when you have your nucleus of your atom and the orbits of which are where the electrons are going around, as they say, the further away the electrons are, the more energy they have. And there's, when you get the first level, the first, or shell as it used to be called, where 2 electrons can be, and then there could be 8 in the second shell, you will find, without exception, the first 2 electrons are at the same exact distance from the nucleus, no matter what atom it is. This is the distance that determines the energy of the electron. In other words, the first 2 electrons going around any atom have the same energy no matter what the atom is, no matter what element. The 8 that go around the second have a higher energy because they're further away from the nucleus. And that's where those up to 8 electrons will reside. What is one of the great mysteries, I don't know how much the people who are really familiar with quantum mechanics and physics is why is that? In other words, if you're one of the first 10 electrons, you are either going to be the 2 in the first shell at an exact distance, or you're going to be one of the 8 in the second shell. There is no in between. In other words, there's not a shell at 1.5. If you got your first shell holding the 2, second shell holding 8, there's no 1.5. But these electrons, here's a kicker. These electrons do move from shell to shell at times, up or down, for various reasons. But they don't know how they do it. And what I'm saying is, they don't, it's not like, here's your first shell, here's your second shell. It doesn't jump like we would jump from one piece of concrete to another. It more or less disappears and reappears at the second level because it can't exist in that in-between. Catch my drift? This is one, I don't know if there's an answer to this. I find this incredibly fascinating. You're down to the nitty gritty now of why things are the way they are. And think of it, if it helps, think of our solar system. The sun's the center, it's the nucleus. You got first planet's Venus, it's a certain distance. Venus is the second planet, certain distance. We happen to be, isn't that interesting? We happen to be at the exact right distance from the sun, Earth is, where it's absolutely perfect. And, the temperature, the amount of sun we get, and so, it sustains life. If it was Mercury, it'd be too hot. If it's Venus, it would be too hot. Mars would be too cold, probably, the next planet. So, but think of it as more or less like that. But here's the deal. Don't forget, and please don't make that common mistake. It's not that, electrons are those points. Like when you had high school chemistry and they show it going around, it's not like that. They're more or less, they're in shape of what they call electron clouds. And we'll, if you like, we'll get into that at a later point. We'll show you and we'll show you how incredibly how complex it is. But no, we won't use any math. So, and you gave me a lot to think about. We got more than you know coming to think about further and blow your mind.